All right, today we're going to be talking about lesson 11.2, which is how to simplify radicals. So when we're simplifying radicals, we have really several basic steps. Number one, you want to do prime factorization. Number two, for if it's an index of 2, which means there's no number on the outside, every 2 prime numbers that are the same, I'm going to pull out 1. If you have an index of 3, then it's every 3 you pull out 1. And so on. If it's an index of 4, every 4. If it's an index of 5, every 5. Finally, any numbers on the outside you multiply together. Any numbers that are inside you multiply together. So let me go through how to do this. Square root of 24, I start off with prime factorization. So remember how we do prime factorization. If I have 24, you can do this by division by primes or by factor tree. So my prime numbers are 2, 2, 2, and 3. So I can rewrite the square root of 24 as the square root of 2. Square root of 2, square root of 2, and square root of 3. So anytime I have 2, the square root of 2 times the square root of 2 is the square root of 4, which equals 2, right? So every time I have 2 of the same, I have 2 2's. That makes the square root of 2 times the square root of 2 is just 2. But I still have 1 2 left and 1 3 left, so those still stay inside. 2 times 3 is 6. I only have the 2 on the outside, so that's my answer. So I do my prime factorization, so 24 is 2, 2, 2, and 3. Since this is a square root, every 2 that are the same, that number can go on the outside. Now just put 1 on the outside for every 2, because the square root of 2 times the square root of 2 equals 2. And then I have left the square root of 2 and the square root of 3, which are going to stay inside. I'm going to multiply them together to get the square root of 6. So my answer is 2 square root of 6. Let's try this with 70. This time I'll do factor tree 7 and 10, 2 and 5. So my numbers are the square root of 2, the square root of 5, and the square root of 7. There are no 2 numbers that are the same. I have 1 of each, so I can't simplify that. So you can just box in your original answer. I can't simplify it because there's no 2 that are the same. Square root of 75. I'll do division by primes, so they can be divided by 3. That's going to be 2 and 5, and then 5 and 5. So I have the square root of 3, the square root of 5, and the square root of 5. This is a square root, so every 2, square root of 5 times the square root of 5 is 5. And then I just have the square root of 3 left. So my answer is 5 square root of 3. This time, notice I have cubed root. So I still do the same thing. I'm still going to do prime factorization. But this time, I have to have 3 numbers to pull them out. So only when I have 3, then I pull out that 1. So the square root of 2 times the square root of 2 times the square root of 2 times 2 times 2. I can even put the little cubes here. So remember that these are cubed roots. That would be the cubed root of 8, right? Which is just 2. And then I have the cubed root of 5. And don't forget that little 3. That's very important. Because there's a big difference between the cubed root of 5 and the square root of 5. So if it starts off with a 3, you have to have the 3 in your answer. Remember, that's a small 3, the index that's there. So that'll be 2 cubed root of 5. So pay attention to the index. If there's no index, then it's every 2. If you have a 3 there, then for 3 of them, you pull out 1. If there's the 4th root, then it has to be 4 of them, you pull out 1, and so on. Now this time, notice here, I not only have a number, but I also have variables. Now, in your lesson, it talks about how if the variable is even and you pull out 1 and then it has an odd exponent, technically it could be positive or negative, so you have to put the absolute value symbol. Now, I am not going to make you do that because it's kind of complicated, and since we're doing the distance learning, it's harder for me to explain that for you. So we're just going to assume that the variables are always positive. So when we assume that the variables are always positive, they're actually going to do that for you in the next lesson. That means you do not have to worry about the absolute value. So the part of the lesson where it talks about the absolute value symbols, don't worry about doing that. So what we're going to do here is we're going to do the same thing with the number that we already did. We're going to do 32. We're going to go ahead and do our prime factorization. So I end up getting 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s. Remember, this is a square root, so every two square roots of 2's, I pull out 1. But then I have another pair of 2. So that means I have another 2, and then I'm left with 1, 2 inside. Now remember, anything that's outside I multiply together, so that's going to end up being 2 times 2 is 4. You can also think about it this way: the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2 is the square root of 16. And guess what? The square root of 16 is 4. And then I'm just left with 1, 2 inside. Now how about here? Well, x cubed means x, x, x. So it's the same thing. For every 2 x's that are inside, I'm going to pull 1 out. So what is the square root of x squared? Well, that's just x, right? So I have x on the outside, but then I have 1 x left inside. Y squared, I have 2 y's. Well, so I pull that y, I pull both of those out, and I have no y's left inside. So my answer is 4xy on the outside. I got the 4 because I had 1 pair of 2, 2 pairs of 2, so 2 times 2 is 4. I had 3 x's, so 2 of those x's came out as 1x. And then I still had 1 left over inside. And then I have 1 y on the outside, because y squared, the square root of y squared is y, but I have no y's left over. So that is my answer, 4xy square root of x. The square root of 2x. This one is very similar, so I'll do this one a little bit more quickly. Again, my first step is to do prime factorization. But for this one, really, I don't even need to do prime factorization because I know that the square root of 16, I'm sorry, I forgot the number here. This shouldn't be the square root. This should be the cubed root. All right, so make sure you pay close attention to those indexes. So I am going to have to do 16. So 16 is going to be 2, 2, 2, and 2. So remember, since this is the cubed root, it's every 3 that I pull out 1. So 1, 2, 3, so I have 1, 2 on the outside, where this is the cubed root. Put this over here. So, and then I have 1, 2 left on the inside. Okay? X squared, that means I have 2 x's. Remember, I have to have 3 to pull it out, so I'm just going to leave x squared on the inside. Y to the 4th, that means I have 4 y's. Remember, for every 3, I can pull 1 out. And then I have 1 left inside. So these 3, that's y cubed. The cubed root of y cubed is just y, so I have a y on the outside, and then I have 1 y left inside. Z to the 6th, that means I have 6 z's. Remember, every 3, I pull 1 out. So I have 3, and then I have another 3. So I have 2 groups of 3, so that's going to be z squared, and I have nothing left over. So my answer is 2yz squared, and then the cubed root of 2x squared y. Now, one last section here. Here I have in parentheses x plus 2 cubed to the cubed root. Well, what does that mean? That means I have 3 x plus 2's. So I can pull the x plus 2 out. Basically what this does is this cancels this. So I'm just left with x plus 2. Same thing happens here. This is the square root of x plus 2 squared. So these just cancel. So I'm just left with x plus 2. So that would be just like if I had the square root of 2 squared. Well, 2 squared is 4, and the square root of 4 is 2. These are opposites. The square and the square root are opposites, so they just cancel. So that would just be 2. So anytime I have a cubed and a cubed root, those are the same thing, so they just cancel each other. So I just have whatever's inside is now the answer. Now, in your lesson, there at the end of the lesson, there is a couple problems that are a little bit tricky. So for example, for number 36, it says make sure you use the formula V equals 15 over 22 times the square root of GD. So it gives you what G is, and then it gives you what D is. So all you have to do for those problems is plug in the numbers and then solve. So for example, if I were to do number 37, I'm going to use the formula it gives me above, 15 over 22, GD. It tells me that G is always 32 feet per second. So I'm going to replace G with 32. And then in the problem 37, it tells me that my D is 3872. So this is 3872. So all I have to do is use a calculator, multiply these two together, find the square root of that answer, and then multiply times 15 over 22. And that will give me my answer. It's the same idea for 38 and 40. You're just using a different formula, but the same basic idea. Hopefully that helps, and we'll see you next time.